In the first video, we learned how to get a spline operating at runtime. We have a simple spline actor that's placed in the world, and wherever we move our mouse cursor, the spline and the spline mesh follow along. If you haven't seen the first video on using splines at runtime, go on ahead and check that out now, as we will be expanding off of the work that we have already done. We want to be able to use our mouse cursor to simply click and spawn a spline. So for now, we can delete our spline actor from the world. To start, go on ahead and open up your player controller, and let's search for left mouse button. Using the left mouse button, when the button is pressed, this is where we spawn the spline, and then when we release, the spline will stay in place. Off of the pressed, let's drag out and get spawn actor from class. Select your spline class, split the spawn transform, and because we're already working within our player controller, we do not need a reference to our hit result under cursor by channel. So just search for hit, and here you can select your get hit result under cursor by channel. Pull off of the hit result and get a break, and let's use the location. We are going to create a Boolean variable for when the left mouse button is pressed and released. Add a variable, and I will call mine isPressed. Pull out and get a setter, duplicate it. So now when the left mouse button is pressed, this variable is set to true, and when it's released, it sets the variable to false. Back in our spline blueprint, let's come all the way over to the end of the loop, make a little space, and let's place a branch right here. We are going to check if the left mouse button is pressed or released, and for that we will use the isPressed variable that we just created. So let's get our player controller reference and get isPressed. If isPressed is true, we will enter the delay node and go back through the loop to reset the position of the first spline point. If it's false, we exit the loop. Now we can simply click, drag, and release, and we can create as many splines as we want. Before we move on, I also want to show you how to implement a snapping effect. So back in the player controller, let's disconnect our location, drag off of the spawn transform location, and get a make vector. Split the location. Off of the X, drag out and get a divide. Drag off of the bottom pin, promote it to a variable, and I will call mine tile size. My tile size is 400, so that will be my default. Drag off of the output and get a round, and after it's rounded, let's multiply it by the tile size again. Let's duplicate this math block and plug in the same for the Y. And don't forget to connect the Z. Now, wherever we click inside of our tile, our spline will be spawned at the closest corner. Let's highlight this math and select Ctrl-C to copy it. Back in the spline blueprint, let's come over to our set location spline point, and let's paste in the same math leading to our end location. And here's the same thing setting our second spline point. Let's not forget to create a tile size variable in our spline class. Also remember to set the default value. Now we have a spline that snaps to every corner of the grid. Depending on what you're doing in your project, you may or may not want to have a snapping feature, but I find it quite handy to know. Next, we are going to start adding more spline points so that we can start getting those nice Bezier curves that we recognize as being a spline. Let's create some space right between our first 2 points. Go over to the set location at spline point for the second point and go on ahead and create a variable. Back at the end of the loop, we're going to create another branch condition. What we want to happen is that when our spline stretches to a certain length, that it creates another point at a certain position. So for our condition, let's get a reference to our spline, and let's get the spline length. And if the spline length is greater than or equal to, if it's greater than or equal to the tile size length multiplied by the point index plus 1. So while the spline length is less than this value, it will not create a new spline point. But as soon as it becomes greater than or equal to this value, it creates a new spline point. So out of the true, let's increment the spline index, package up our math block, get a reference to the spline, and select Add Spline Point at Index. Plug in your spline index, and it doesn't really matter where the position of it will be at, because after it goes through the loop, it's going to be reset over here at the set location at spline point. But just so that it does not glitch every 1/10 of a second, I will go on ahead and copy the hit result, and I will just use the location for the position. Out of the false of our spline length condition, don't forget to also connect that to the delay node. I don't know if you can see it on your screen, but we now have more spline points being generated. Our spline mesh remains between spline point 0 and 1, so let's work on creating more spline meshes next. Back toward the beginning of our spline loop, let's get the point index and plug that in for the point index that goes to the set start and end of our mesh. And for the first point, let's do the same thing. So let's do -1. After a new spline point is created, we want to create a new spline mesh to go with it. Back toward the beginning of the function where we added our spline mesh component, go ahead and copy all the related nodes. What we are doing is we are creating a new spline mesh component and then resetting our mesh variable to this new spline component. Then as it goes back through the loop, that new mesh is being positioned between these spline points. We can now click and drag to draw more spline points and spline meshes. The spline mesh that we're using is just a simple box and does not have much geometry to it. Let's work on optimizing our geometry so that we can start to get those smoother, unbroken curves that we are looking for. I want to briefly use Blender to show you how you should have the geometry set up for a spline mesh. Go ahead and delete the 3 default actors. Add a plane. I am going to scale mine on the y-axis by 3, and I'm going to reposition it along the x-axis by 1. This will make the origin of the geometry right here on this edge in the center. Over in edit mode, use the edge selector, select this edge, Press E to extrude, X to focus on the X axis, and over here I can click and I can just set this value to 2. I can also just press A to select the entire geometry and select the loop cut and make cuts along the Y axis. You can make as many cuts as you need. I don't think you have to go too crazy with making so many loop cuts. However, the more geometry that you have, the smoother the curves that you will have in your spline. Back in object mode, make sure your plane is selected and export as an FBX. Make sure you have your location and a file name. For the save settings, I'll just select mesh, unselect bake animations. I'm not creating any armatures, but what's really important is to make sure that you have your forward axis set for X and your up axis set to Z, as these are the axis settings for Unreal Engine. Back in the engine, come over to the Add Spline Mesh Component node, and let's swap out the simple square for our new square that we just made in Blender. Make sure you do the same thing for the second Add Spline Mesh Component node that we added in our loop. My geometry is a little bit larger, so let me make a couple adjustments. I'm just going to double my tile size variable to 800. The geometry that we can see bending is looking smooth, but we still have these gaps at the points in between where they're being created at. What's happening here is that this mesh is being created right here at this point. What I want it to do is I want the mesh that's making the bend to start back here at this point and extend all the way around to this point. So back in the loop where we set the start and end of our mesh component, I'm going to offset the first point back by one more section. Well, my theory is only halfway there so far, but we're having some maleffects. For the second point, let's do the same thing, and we will offset it by 1. Now we are finally getting some smoother curves in our geometry. I'm going to readjust the tile size again. Right now I have my spline coming this direction and then cutting this direction, and this curve is very exaggerated. If I want this curve to not be so pronounced, I need to clamp the tangent length. Back again at our set start and end of our mesh component, let's come off of the tangent and search clamp, and let's clamp vector size. Right now, the length of our tangents are able to extend as far as the length between our points. If I reduce the maximum length that the tangent can extend, let's say 100, then I should now have a less pronounced curve. I can even set this down to 50. Now the curve looks much sharper. If we want to, we can undo the snapping effect that we created earlier by simply connecting the X and the Y back into our make vector. You can also keep playing around with the tile size.